So again, I think I have taken a slightly different one because I'm choosing the values better to illustrate some important points. Okay, this values are slightly different. So again, this is some historical data, and usually if the historical data is good, it will show correctly what you want. Okay, that's what nature has done, right? So it is trying to do that. So probability of sunny given sunny is 50% of the time. Probability of sunny, so cloudy given sunny, the previous day was sunny, is 0.375. Probability of rainy given sunny is 0.125, like that. So whenever previous day was sunny, there's a very little chance of the next day being rainy. That's what it's trying to. Similarly, whenever something is cloudy, there's a very high chance of the next day being rainy. So it sort of seems reasonable, and whenever it's rainy, often it continues to be rainy the next day. Okay. So this is a 5-day forecast. Okay. So we have to start somewhere. So remember, first order Markov means I need one history which I always need to know, right, to start my process. So here let's say day 1 is our first day. So day 0, that is the previous first Markov in my history, has to have one element. Let us assume that is sunny. So what will be the weather on day 1? How do you find that out? So if I want a 1-day forecast, given that it is sunny, right, what is the next day forecast? Okay. So if you look at this, can you tell me, given that the previous day was sunny, what is my best prediction of the next day? If I told you today is sunny, what will you tell given the historical data? So 1-day forecast if I want, historical data, what will you tell me what the next day will be? We will say that the next day can only be either, see, given today is sunny, next day can only be sunny or cloudy or rain. It can be only one of these 3 weather conditions. Out of these, sunny is the most probable, right? It has the highest probability. So given that today is sunny, my prediction for next day will always be sunny. Okay. So that is what we are saying here. Okay. Now, so day sunny is the most probable, right? So now if I want to find so that's what I'm doing step by step. So given day is 0 sunny, we look at the transition probability of given is sunny. It can either go to sunny or cloudy or rainy. Among these 3, I am looking at the maximum probability. So among 0.5, 0.375 and 0.125, I find the one with the maximum probability. This is the one with the maximum probability. These 2 are much smaller. So I say the 50% chance the next day will be sunny. So that is the most probable, and therefore I choose sunny. Now if I want to make a 3-day forecast, I cannot continue with the same logic. I will come to why I will not do it. That is called the greedy algorithm. We will come to it. So you can say, so if I want a 3-day forecast, my next day forecast is sunny, highly probable. So today I said sunny. Based on this, you are going to say next day is definitely sunny, right? If I am looking at 3-day forecast, then tomorrow, since you made a guess, it's going to be sunny, right? You can say, okay, now that tomorrow I know it is sunny, what is the following day? Now with this matrix, because tomorrow is sunny, the highest probability for next day will also turn out to be sunny, right? Now again I am going to make sunny as an assumption, right? And then ask what is the 3rd day? Again, because of the same row I am looking at, it will turn out to be sunny. So if I give you sunny today, right, or yesterday, right, and ask you 3-day forecast, today and 3-day forecast, if you do each day dependent on the previous day, there is only going to be sunny, sunny, sunny. This is called a greedy algorithm, because we are saying I am going to make errors, but you are not accounting for it. You are always giving full probability to the next day. So remember, if today is sunny, tomorrow if I make a forecast, among these 3 weather conditions, sunny, cloudy and rainy, only sunny was highly probable, therefore I took sunny, right? But there is a 50% chance I made a mistake, right? But you are ignoring it, and so you are saying, okay, tomorrow I am going to say that is sunny. Now based on this sunny, you are going to ask what is the next day forecast. Again you are going to look at this, but again because you are only looking at only one day, you are going to say sunny, okay? But there could be that I made, cloudy is a lesser chance, but the 2-day forecast, if I take another path, that can be more probable than this path. Okay, we will come to this idea of what is the difference between what we call as a greedy algorithm and finding out the best path. Okay, best weather prediction. Okay, the greedy algorithm need not always be the best. Okay, so so I'll come to the greedy approach. First we look at the more practical way of doing things. Okay, and then we'll see why greedy is not a good idea. So if I look at this is actually my student has worked it out, so I thank my students for all of this. So if there are 3 days forecast we are interested, right? Now each day, how many each day can be in which of the 3 weather conditions? So let us say I know for today is sunny. Okay, that is given, that is a observed weather, that's already known. Now next 3 days I am planning to predict the weather, right? Now each day, there are 3 days, each day it can be sunny or cloudy or rainy. So it is 3 weather conditions I can be, or what we call as any one of the 3 states. Now the next day also it can be any one of the 3 states. Now you can ask how many different types, how many weather condition, how many different ways can you have the for 2 days? It can be sunny, or sunny, cloudy, cloudy, rainy. So immediately you see that you're looking at all kinds of permutation here, right? So sunny and rainy, rainy and sunny. So both the orders become very, very important, right? So you're looking at, it can be sunny, 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 rainy, rainy, sunny, all possible ways that you can have. You can have these weather conditions occurring. So first day can be 3, next day can be another 3, right? So it is 3 into 3. So 3 squared, 9 different paths or 9 different variation types of weather 2-day forecast can happen. Now if I am looking at the third day, so first day there were 3, next day there were 3, third day there were 3, right? So 3 into any one of those 3 into any one of the 3 on the third day. So 3 into 3 is 9, 9 into 3 27. So 27 different orders of these weathers can happen. So first day can be sunny, sunny, sunny. One day, 3 days can be day 1, day 2, day 3 can be sunny, 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 or sunny, sunny, cloudy, or sunny, sunny, rainy, or sunny, cloudy, sunny, sunny, cloudy, cloudy, sunny, cloudy, rainy. You can do all this, and if you count, there will be 27, right? Because 3 on any one of those 3 on the first day, multiplied by any one of the 3 on the next day, multiplied by any one of the 3 on the third day, 3 into 3 into 3, which is 27 different weather conditions, right? So 1, 2, 3, if you count, there will be 27 such rows. Okay, for each one of those rows, I will find out. So given right, that already I know it is sunny. That's an assumption I'm making. The previous day we are saying it is sunny. Okay, so all of them will start with sunny the first time. Okay, because the previous day was always sunny. Sunny to sunny, sunny to cloudy, sunny to rainy. It's going to go in any one of those 3 conditions, right? So if you compute, so it will be probability of sunny given sunny, sunny given sunny, because all 3 are sunny, right? If you look at this guy, it was starting from sunny going to cloudy, then sunny, rainy. So probability of sunny given cloudy, then sunny given probability of cloudy given sunny, probability of sunny given cloudy, probability of rainy given sunny, and we compute using the transition matrices here, all of this, and we are calculating the total probabilities here, right? So this is the probability of each one of these 3-day forecast. So we have to compute 27 different paths or 27 different patterns of weather, right? Sunny, 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 3-day forecast, sunny, sunny, cloudy, sunny, rainy, cloudy, so on. Then look at which one gives me the maximum probability, right? So there's 0.125 something. So if you see, this guy is the most probable because it is 0.158203. So this is the best solution. Cloudy, rainy, rainy. Okay, this is going to be given the previous day was sunny, the probability of next 3 days being cloudy, rainy, rainy is my best weather forecast. Okay, so if I had only this information, this transition probability, given it is sunny, I will say next 3-day forecast is cloudy, rainy, rainy. Okay, so that's what you are going to say. Okay, originally, if you look at the matrix, the greedy algorithm, because sunny given sunny was very high, it would have put sunny, sunny, sunny. That is only 0.125 probable. This is 0.15 probable. Okay, remember we are going to make mistakes. The 3-day forecast is going to be with the kind of information that I have, only the transition matrix. I have about 15%. This is most likely. So we are among all these. This is most likely, most probable. So I am going to choose this and say this is the best 3-day forecast I can have. Okay, so why did cloudy, rainy turn out to be highly probable? That's because you see that even though given sunny the first probability was very low, the next two probabilities 0.625 and 0.675, they are highly probable. So the next two paths made up for the degradation in the first path. Okay, so in the first path this was 0.5. The greedy algorithm then stuck with 0.5. So it was always 0.5 into 0.5 into 0.5. Here, even though it started with a smaller probability, the next day was smaller. When I went for the 3-day, the subsequent two paths turned out to be giving a higher probability, and so I got 0.675 and 0.675. Okay, so therefore, we have to evaluate all of these paths and then only find. That will always give me the optimal path. Okay. So, just to remind you, if I do the greedy, it will be, if I had sunny, then next day will be sunny. Because it became sunny again, next day will become sunny. So, always I will be stuck with 0.5 because these two are smaller than this. Especially if this was 0.45 and this was 0.43 and this was something remaining, 0.45 slightly margin more than 0.43, it will still, the greedy algorithm will choose that. Okay, but if you are looking for the best path, so the best path or the best probability, best sequence is not often got by the greedy algorithm. The greedy algorithm is a simple way of doing it. Otherwise, we have to do the complicated search for all possible paths and find the one that gives maximum. So, in that non-greedy one, what happened was sunny went to cloudy, from cloudy I went to rainy, so 0.375 into 0.625 and then again rainy. So, therefore, this 0.375 into 0.625 into 0.675, that gave me a larger probability than the greedy algorithm, right. So, it's always good to look for all, that is the optimal solution. Look for all possible paths and then find the one with the maximum probability. Okay, this is 3-day forecast. Now, in 3-day forecast, how many paths did I have to look for? First day there were 3 weather conditions, next day there were 3 weather conditions, final day there were another 3 weather conditions. So, 3 into 3 into 3, 27 different paths. Now, what happens if I want a 5-day forecast? Okay, if I have 5-day forecast, then the first day, again we are assuming only 3 weather conditions, rainy, cloudy or sunny. So, first day there is 3, followed by another 3 for the next day, followed by another 3, 3, 3. So, this is, so number of states is 3, number of events or number of time stamps that I am looking is 5, number of days or time units I am looking is 5. So, always these paths are the number of states 3 raised to the power of number of time units, which is 5. 3 raised to the power of 5 is 243. 3 raised to the power of 3 is 27. If I had a 4-day forecast and 3 weather conditions, 3 raised to the power of 3 into 3 into 3 into 3, 3 raised to the power of 4, which is 81. Okay. Now comes the idea, oh, competition. I told you IMD, one of the heavily used supercomputing facilities are by the weather prediction guys. Okay, they need lot of compute power, and you can see immediately what will happen. Okay, and this is true for speech recognition, handwriting recognition, many of the other things. A simple speech recognition problem, or not a very fancy one, will have at least something like 3000 states, 2000 states, 2500 states. Okay, and the number of time units, even one sentence, let us say, is about 5 seconds long. A 5-second long sentence will take about 500 our time MSCC vectors I talked about. So, there will be 500 such time units that will come. So, if you look at it, 3000 states, and each time 3000 into 3500 times. So, 3000 raised to the power of 500. Okay, and that if you want to solve, you cannot do it in this life. There's not enough computers, there's not enough supercomputers to deal even a simple calculation like that. Okay, so 3000 raised to the power of 500 will take forever for the compute facilities to do something like that. Okay, it's just impossible to do it. Okay, in anybody's lifetime, it will take more than the universe's time, right? So what happened was, there is a brilliant algorithm that Viterbi came up with. Okay, and this is called the Viterbi algorithm. You would have seen this in many applications. Previously, when I was talking about signal processing, I told you there is an algorithm called the fast Fourier transform algorithm, which is an efficient way of using the DFT, the discrete Fourier transform. So in 1965, the fast Fourier transform algorithm made a remarkable change, and that is why the whole field of signal processing came about, the digital signal processing, which drove much of the research in the from 60s to almost about 2000, right? So they have been the driving force. Now the data driven approaches are coming. Viterbi is another algorithm that came in 1973, and Viterbi is another amazing algorithm that changed, made compute easily doable, right? It is still giving an optimal solution. It is just that do it efficiently. Okay, so otherwise, as I said, even one sentence, it's impossible to do in the brute force way, the way that we are doing here, right? If I had to do this, even for one sentence for speech, all the supercomputers in the world, taking billions of years, cannot solve the problem. Okay, if you are trying to do it brute force, one by one, and finding out what is the maximum. So many of you, so this is the basic idea of what is called the Viterbi. It is not an approximation. It will give you the best solution. Okay, so remember, what is the problem? That if you have n states and we have a sequence of time t, capital T timestamps, or time, we use timestamps or time units or whatever it is, right? So n states are there, each n into n, I have to do it for capital T times. So that is why the total number of paths will come out to be n raised to the power of t, right? So that we saw it before, right? So here 3 into 3, so 3 raised to the power of 3 is 27 paths will come. So you will see there will be 27 paths. If there are 5, there will be 243 different paths. Okay, 4, 81, 3 to the power 6, 3, and if you have 106 time units, 100 raised to the power of 6, 1 billion paths. Okay, now in that is only simple things. If you look at speech, 3000 raised to the power of some 500, capital T will be 500, and that slowly you will see it's exponential. So there's not enough compute power in the world to do such kind of calculations. So Viterbi is the guy who came up with this idea. So you might not know who Viterbi is, but I'm sure you've seen or heard of this algorithm in communication, right? You use it in many different applications, and just to give just a little bit of some side information. Viterbi is the guy who actually founded, I mean, he and a professor in if I'm not mistaken, from Princeton, I forgot. They both started before Qualcomm came. They both started a company that used to do this this trucking business, right? So how to optimally schedule these trucks, and so that the in the basically scheduling problem, what route should you take, and this truck should come here and then go here, so unnecessarily it's not going up and down, wasting time and your fuel and other things by not taking cargo, right? And similar idea, now based on that, they started with that. See, all this Ola, Uber, all these things basically look at scheduling, right? You are located here, there's a request from here which is the closest, and they also put in other parameters like how long have you not got since a last customer, and they try to push you a little bit. So there's some algorithms that do it. So Viterbi and the other I forgot his name, started this company, right? And then they came up with this whole idea of spread spectrum, and from which came the wireless communication standard, which is called the CDMA standard, which was adopted by North America, and the Europe and others adopted the GSM standard, right? And one of the original standard, one of the people involved in the original standard from Ericsson's side was Professor David Koil-Pillai, who is actually a professor in IIT Madras, right? He's currently the head of the department also. So, this GSM and CDMA standard came up, and basically Viterbi started that Qualcomm basically, and I mean, which started with the trucking, then they slowly matured to a company that does the spectrum, and therefore they came up with the wireless communication standards, CDMA, and then Verizon, and many of these companies are riding on that. Of course, now all of this are sort of combined, and now you almost 5G is sort of takes best of everything, right? And then these guys slowly evolved to Qualcomm being this Snapdragon chip manufacturer, right? So all your mobile phones now, right? You talk about Snapdragon 888, I don't know, Gen what it is, 1 or whatever it is, right? So which is the latest, and then they have some other things coming, right? So most of your mobile phones are driven either by MediaTek or Snapdragon chips. So Snapdragon is parent company is Qualcomm, right? Qualcomm only makes this, right? So Viterbi is the guy who was was instrumental for all of this. I mean, he started the company that's doing all of this. Okay.